Hello everybody, this is lecture number 34. Okay, and we are into chapter number 9, and this is 2D elasticity. Okay, problems. Okay, so far we have derived the strong form, and then we also derived the weak form. Yeah. Okay, so the weak form what we have so far is like this. So this is gamma t, then w tilde t, then t tilde d gamma minus omega. Then we have del s omega del s w transpose of that, then d tilde del s u tilde d omega. Okay, then we have plus. Okay, so let's write here. So plus integration over the whole domain, then w tilde transpose b tilde d omega, and everything equal to 0. Okay. So here this is how the weak form is given, where all those things we know already. So to be explicit, we can write w is equal to wx, wy. Similarly, u is equal to ux and uy. Okay, b tilde is equal to bx and by. So all of them, all vectors. T tilde is equal to tx and ty, which are given. Okay, so we have also written is t bar here. So okay, so okay, then we have so this done, this done, del s. Okay, so del s is equal to del over del x 0, yeah, then del over, then it's 0, del over del y, then we have del over del y, del over del x. Yeah, so like this. Okay, so that if we have u here, for example, if you have ux and uy, then we will have ux, this will give us epsilon xx, this multiplied by this one, this multiplied by this will give us epsilon yy, this multiplied by this will give epsilon xy. So this is how. Okay, then we have d tilde, which is equal to e over 1 minus nu square, and then we have 1 nu 0 nu 1 0 0 0 1 minus nu over 2. So this is what the d vector is. Okay, so have this. Okay, so everything is given here. Now next thing is of course this is for a plane stress problem. Okay. So, this is a material property basically, this is depends on the material, yeah, and given this weak form, we can now find the solution. Okay, so we can start with easy ones that we know already. So, also call constant. Now, element type, we will choose elements. So, we can take any kinds of element, could be a triangular element, 3 noded one, or we can take a 6 noded one and so on. Yeah, so let us start with this one. This is called CST, constant strain triangle. Okay, so this we have already studied. So, this is the 3 noded. So, this example 3 noded element. Okay, and we know that we can write it as like n is equal to, in general we can, I think first let us formulate in general. Okay, so these are all the examples. So, this is example will be like this one, number 2 example will be 6 noded element like this. So, it is called the linear strain triangle, linear strain triangle. Okay. So, or also called 6 noded element. Okay. Number 3 could be quadrilateral element. So, random, like we have done this quadrilateral element. Okay, that we know this is will be isoparametric. Okay, so these also can be solved by using the isoparametric elements. We can transfer and we can do it. So, we know that, but this we will definitely use isoparametric elements, so that it is easier to solve. And there will be subtypes, and could be a rectangular element, okay, and B could be even a square element, right. So, a square element. So, this is 4 noded, yeah. So, this means 4 noded, and this is all 4 noded only. So, a square element, so 4 noded basically this is. Okay, so it is possible that you have more than 4 elements. You can take a node in the middle, or you can take 8 like this, one more point in between, that also you can take in all the cases also. Anyway, so there are many possibilities, but we will look at some of them. However, we are going to solve in general, yeah. So, we will just use for general formulation. Okay. So, general element, general n noded element, n noded element. Okay. So, that means we can write u. So, u tilde will be equal to summation of like we can write it like this, summation of n I, where I equal to 1 to n I x y, okay, because u tilde is a function of x y, multiplied by u u tilde I, okay, where u tilde is nothing but ux and uy basically we are talking about, yeah, and actually this is ux and ui are both function of, so ux is also function of xy and uy is also function of xy, yeah, okay. Then ui tilde is ux I and uyi basically, yeah. So I equal to 1 to n, right, okay. And this is the one that we know already, right. So ni xy is the shape function, you call it shape functions or interpolation function, okay. Okay, so once we have that, now we have to put these values into the weak formulation. Again we also have to write w as well. So we have w as well in the equation, so here, so we have to write that also. Again we will have w vector corresponding to all nodes the way we have u vector. So ui for example therefore corresponding to all nodes. So this corresponding to, so these are the basically the displacements, nodal displacement, you call nodal displacements, nodal displacement. Nodal weights, so you can also have the weight w tilde xy as a function of, so I equal to 1 to n, and then we will have n I xy, and then we have w tilde I, yeah, where w tilde xy is nothing but equal to wx xy and wy xy, yeah, okay. So done. Then we have shape function same as earlier, and then w, we had wi is equal to wxi and wyi nodal weights, okay. So these are actually, these things are constant basically what I mean. The similar way these are the nodal displacement which are constants, okay. So these values we need to find out, okay. So once we have that, we can put in the original equation, okay. So now put the u tilde xy and w tilde xy in the original weak function. So let us now start putting these values of ux and u tilde and w tilde in the original weak function, but one term at a time. So the first term is this, okay. So this comma t and then w tilde t, yeah, okay, d, right. Okay, so this will be equal to, we know that this is nothing but summation n I and then w I tilde, right. Okay, and here we have I equal to 1 to n, and then we have transpose of that, and then t tilde d gamma. We want to write this I equal to 1 to n n I w I tilde is equal to we have what? We have something like this. So, this will be equal to nothing but n1 w x1 n1 n2 w x2 and so on n n w xn, and then here we have n 2, sorry not 2 but n1 w y1 n2 w y2 so on n w n w yn, like this. Yeah. Okay, so this is well, this is not like this. This will be added like this one. Okay, and so on. Yeah, similarly here is added. Okay, so like this. Okay. Okay, so this we can also write like this is equal to n1 0 n2 0 n3 0 and so on, and we have n 0. Yeah. Okay. And then we have 0 n1 0 n2 0 n3 0 n, and then we have w, say w x1 w y1, right, w x2 w y2 and so on till w. So, we will have till w w y n. Yeah, so this is how this will be. Yeah. So, the idea is the first one n1 times w x1. So, n1 multiplied by w x1, second is w y1. So, here it will be 0. So, this will not be taken. So, then n2. So, then n2 multiplied by w x2. Here also the similar thing 0. So, n1 w y1 0 here, then n2 w y2 and so on. Yeah. Okay, so this we can say this is equal to n. So, let's call it n vector. Yeah, so let's call it n tilde, and then we said this is w, big W. Let's call big W, but e tilde. Yeah. Okay, where n tilde is nothing but the one n1 0 n2 0 and so on, and then we have n 0, this will be 0 n1 0 n2 and so on, then 0 n like this one. Okay, and then w e tilde is equal to like this w x1 w x y1 w x2 w y2 and so on w x n w y n and transpose of that. Okay. So, this is how w is a vector. We can also have, similarly we can write okay, right now we can have just like this one, we can come back to u tilde later on, but as far as now is concerned, we can put this value now here, right. So, n tilde w e tilde. So, basically here this value will be equal to, so we can write now. So, again the this okay. So, gamma t then what do we have, this value, right. Okay. So, w tilde transpose t tilde d gamma will be equal to gamma t, and then we put this one. So, this is equal to n w e. So, we put there. So, n w e both tilde transpose t transpose d gamma, and which is equal to nothing but w is constant, right. W is constant. So, w e we can bring it outside. So, let us write this is equal to rather w e tilde, this will be transpose, and n tilde transpose, okay, maybe we write below. Okay. So, this is equal to here gamma t w e tilde transpose gamma t n tilde transpose t transpose d gamma w e transpose, then integration n e transpose t tilde d gamma. Yeah. So, this is how this term will be. Okay. So, let us call it 1, we get like that. Similarly, the second term, okay, second term is this minus and del s tilde w tilde transpose d tilde del s tilde u tilde d omega. Yeah. So, like this is now we have to equal to what? We have to find out. Yeah. So, let us look at this. So, we already know this one, what the w is, right. So, if you put it there, how it looks like. So, w is, we know so far that w here is given as n tilde times w e tilde, that is we have written, right. So, this is w. So, w is, so here, so this is nothing but n I times, this is nothing but W only, right. So, this is W, this is W tilde. This W tilde is given by all these n times W e. So, we will use the same relation here. So, W tilde n W e, okay. And then on top of that we are going to apply del S tilde, okay. So, W will be equal to del S tilde W e, sorry, n times n basically. So, times n, then W e, okay. So, W e here, okay. Okay. So, this is a vector of all nodal weights basically. So, this is not a function of x y, whereas this is a function of x y, okay. Okay. So, if you have that, then what we can see here, this will be equal to, and let us call this as a B matrix, okay. Let us call it the B matrix. So, this is a B tilde and W e, okay, where B tilde will be equal to del S tilde n tilde, this is n tilde like this, where this will be equal to, if you see, that really means what is the meaning. So, this one we know is of this type. So, they will have del over del x, 0, del over del y, then we have del over del y and del over del x, yeah, okay. And then we have here, it will be this multiplied by this. So, x y n here, right. So, here we have n. So, n matrix nothing but n1, 0, n2, 0 and so on. Here it will be 0, and then n1, 0, n2 and so on, right. So, we have till 0 here and we have till n here, like this. We can see here that this multiplies by this. So, del n1 over del x, then this one 0, right, this. So, we can actually make, so this becomes del n1 del x. So, this is 3, this is 3 by 2, this is 2 by n, yes, accordingly the number of, so this is 3 by 2, this is 2 by, this is 2 by, so this is 2 by 2n, right. So, this is 2 by 2n, okay. Yeah. So, hence it will be n times 2n, okay. So, B matrix will be 3 times 2n, okay. So, we can see, we can actually write how the B matrix will look like. So, B tilde will be equal to, so del n1 del x. So, we can go here. So, first one del n1 del x, so equals here. Second one, this multiply by this 0, then this multiply by this again. So, del n2 dx and so on. So, first will be like this, is 0, del n2 over del x 0 and so on, and then you will have del n del x 0, okay. Now, second one will be, again we can see from here. So, this multiplied by this, so 0 and 0, then here it will be 0 multiply by 0 and this multiplies by n1. So, del n1 del y, so we get 0, del n1 del y 0, del n2 del y and so on, 0 del n del n del y. Okay, done. Then we have the last one, last row will be this one, this multiplied by this one. So, we get n1 y1 n1, so this multiplied by this. So, we get n1 del y, next one will be del n1 del x and so on. So, what it means is you will have del n1 del y, del n1 del x, and so on. So, del n2 del y, del n2 del x, similarly del n del y, del n del x. Okay. So, we get this B matrix, yeah, and this B has the content is like this one. You can see that this is 2 by 2n, right. So, this is 2 by 2n size, yeah. Sorry, 3 by 2n size. So, this is 3 by 2n size. Okay. Okay. So, what we got? We got B equal to del S n, yeah. So, this is what the B is. So, this whole thing is BWE, right. So, we will put here BWE, right. Similarly, this one, the way we have worked for W, similarly we can also write U is equal to N W U E, U, big U E, like this, yeah. We can write like that, where N is a matrix that we know this is the N matrix. Same in N matrix we can use, because we know that W and U they work in the similar way. So, we can write U tilde which is equal to summation I equal to 1 to n I x y multiplied by U I tilde, yeah, and this we can write as n tilde multiplied by U e tilde, where U e tilde is nothing but equal to U x1, U y1, U x2, U x2, U y2 and so on, and that is still U x n U y n transpose of that, yeah. So, these are what? They are the nodal coordinates. Okay. So, what is the meaning of that? The meaning is that any element, like let us say we have some element, three node elements, so it will have like this. Let us say we call it number 1, 2, 3, then it will have 6 displacements basically. So, we will have like this. So, this is U x1, this is U y1, this is U x2, U y2, this is U x3, this is U y3. So, these are the nodal displacements, right. So, that is the meaning of that. So, this is what that is. So, here also we got the same thing, and hence the way we found this is the way we said del S W tilde is equal to del S, W was nothing but N tilde W E tilde, which we wrote as B tilde W E. Similarly, we can write exactly similar del S tilde U tilde equal to del S tilde N tilde U E tilde is equal to B tilde U E tilde. Yeah. So, this both the things now we want to put in the expression, this expression. Okay. So, this we know now and everything we know now. So, we can write basically the number 2, the second term we write omega, this is minus basically, and del S tilde W tilde T D tilde del S tilde U tilde d omega, yeah, will be equal to minus here this is del S W equal to B W E, right. So, B W E transpose D and this is B tilde U E is equal to, so is equal to minus, again this one we can expand and this also is constant basically, right. So, what we can write is minus W E tilde transpose then integrate B tilde transpose D B transpose B, yeah, D omega times U E transpose like this. Okay. So, what you see? You see like this. Okay. So, basically what is this one? This is what we call the stiffness matrix. So, this is we can write equal to minus W E tilde transpose times K, this is a K, this is a K tilde K matrix and U E tilde, okay, where K tilde is B tilde T D B tilde D omega, okay, is what? This is a stiffness matrix. Yeah. So, basically we have derived the stiffness matrix basically. This is what it is, very simple format, right. So, we have seen for heat transfer problem also, yeah. So, where B had it was not exactly 3 by 2n, rather it was 2 by n there, but here we have different size, that is the only difference, but this is what the stiffness matrix is. But in any case we got this one from 2. So, let us call it as equation number 2. Okay. Now, the third part we have is W tilde transpose B tilde D omega, okay, integrate over omega, and this will be is equal to This one we know now, we write is as n n tilde multiplied by W e tilde, right. This is transpose B d omega, which is equal to, we can have W e transpose omega n tilde transpose, right, multiplied by B d omega, like this one. Yeah. So, this one we have in common, right. So, this we know that this is the we can also see here. Yeah. Okay. So, you can also see the size basically. So, this one, this has with transpose, basically with transpose we will have 1 by 2n. Every node has w x and w y. So, 1 times 2n. Okay. This one is, after you transpose, this becomes 2n, this becomes 2n by 2, 2n by 2, and this one is 2 by 1. Yeah. Hence, it multiplies and becomes 1, that makes it is a scalar basically, right. Okay. So, we get this, and let us call it, this is equation 3. So, combining 1, 2 and 3. Yeah. Okay. So, what we get into the weak form, and what do you get? So, from 1, let us go back, find out where 1 is. So, okay. So, here goes the 1. So, we will write like this one, W e transpose and n transpose t, okay, over this is the gamma. So, this is W e. So, let us go. So, W e transpose gamma t n tilde transpose t tilde d gamma, okay, then minus W e transpose omega, then we have B tilde d tilde transpose d b, just b, not transpose, b d omega, then u e tilde. So, okay, so this is also tilde. Okay. Okay, and then plus W tilde transpose E, and then N tilde T and B tilde d omega is equal to 0. Okay. Now, we know that W is arbitrary. So, we know, right. So, since W is arbitrary, W tilde is arbitrary, that implies that W e is also arbitrary. Hence we have this in common, right? So, this is common, this common, this common. So, the way we have done earlier. So, we will get rid of this one. So, what must be true is this equal to this one plus this one, because this is minus here. So, this will go this side and we have this plus this. So, we can write that, what we can write? We can write like this. Hence, we have b tilde t d tilde b tilde d omega. Yeah, so this is omega, then u e tilde, yeah, okay, is equal to, we have first is del t, and here we have n tilde t and t tilde d gamma plus omega n tilde t b tilde d omega, yeah, or we can write. So, this we know is k. So, we call it this one is k, rather let us call it k e, yeah, tilde, k e tilde. So, that this is for the element stiffness matrix, that implies, yeah. So, or we have k e tilde u e tilde is equal to f e tilde, yeah. So, this is what this is a force vector. So, this is a force vector. So, this is basically, this one is coming from the, so the difference is this coming from the boundary or traction, this is boundary traction, and this is coming from the body force, yeah, okay. Okay, so we have this this equation now, okay, and we are used to that. We know that this is a stiffness matrix, this will be displacement vector, and this is force vector. Okay. So, and the force vector are two types. One comes from boundary traction T, which is given, the other comes from the body force, which is given, and this is how we it will have both the components. Yeah. Okay. So, this is the derived from the general formulation. Now, only thing is, now next we have to adapt it to different kind of elements. So, we will look at for 3 noded element or for 6 noded element or for the quadrilateral elements, yeah, how the stiffness matrix will look like. So, there also we know that actually the everything is given here already. So, only thing is we just put the different n there, automatically we will get it, yeah. So, this is valid for all kinds of elements. So, we will now just customize this for this one. So, we will take in the next video lecture, we will take a 3 noded element as an example and see how the stiffness matrix looks like, okay.